Okay. So I am Su and today our topic is routing in multi-radio, multi-root wireless mesh network. First, first is the menu. We will have the introduction of this paper, then talk about why overall the new root metric. Then we'll talk about their metric, which is called MRL2RS protocol. Then there will be their implementation, test bed, and the results, and finally the related working procedure. Okay, first the introduction is the reason why the authors of this paper want to have a new metric is because they found out recently there's a community wireless network which mostly there's a problem. One of the main problems facing this kind of network is the reduction in total capacity due to the interference between multiple simulation conditions. So, and they find out one result of this is to use the multiple node with multiple radios. So there will be a multiple transmission. However, by using the multiple radios per node, there may be some problems. So that's why. And the problems I will talk about on the next page, and this is the reason why they want new routing metric, because mainly the most algorithm of this is using the shortest path routing algorithm. But by using this, there's two main problems. One is when there's multiple radios, the shortest path while using shortest path routing, most of the traffic will be over on the slower link, but not the faster link when the two links are on different radios. And the other problem is that even if there are two nodes there are same radios, using the shortest path link mostly will use the same channel, but not the real quicker one that use different channels when using the shortest path link. And but there may be other metrics, and what the example of the authors provide is the TX, and the TX is the metric is called expected termination count. However, the expected termination count or the ETX method also they just consider loose rate but not the bandwidth or the channel diversity, and also they may route traffic over slower links or on the same channel. So this is the reason why the overall this paper wants a new routing metric. So what the metric they have provide is called the MRLQRS protocols, and which is this method is to using the combined LQSR, or it's called source LQSR is source root link state protocols delivered by SR, and using this source they combine with their own new metric called WCETT, or the weight cumulative expected termination time. So the assumption and the WCET that formula is under there the 1 minus beta and those things, and the ETT in this is from the ETX what they have just found previously and provided with the packet size and the bandwidth. So this their protocols. Yeah. Then here is the implementation. So what they implement is they use the mesh connected layers MCL as the window driver and provide mostly their links in that layer. And the visible network adapter involves AD and OC mesh as the standard Ethernet link. Also, the LPS are modified to include internal metrics in routing message. And by this implementation, this can support both ETX and WCET. The channel numbers encoding in the also is encoding in the measure. The next is the spec.
And for the testbed, so we evaluate the performance. The author deployed 23 node testbed on a single floor, on a single building floor, and the each node is an HPD530 OPC, and it's running on the Windows XP and equipped with one 802.11a card and one 802.11c card. And then the author selected non-overlapping channels for its radio and to minimize the internal radio interference. And the nodes remain stationary throughout all runs. And the author used 100 random source, and it's running a 2-minute TCP flow. And this controlled environment let the author isolate the benefits of multi-radio diversity and link quality routing without confounding mobility or external interference. And then the result is the bandwidth estimation. The packet pair for ping output for 402 and 402.11a and 402.11c radios are currently distinguished link rates and from 6 Mbps to 54 Mbps. And then the single radio baseline using only 802.11a radio, the WCEDD routing yielded a media TCP throughput of 1,601 kbps, which is 16% higher than the ETX routing and 38% higher above the simple shortest path routing. And we quote the impact of beta on this paper is the varying diversity. The weight beta showed that setting the beta around 0.5 maximizes the throughput by balancing airtime efficiency and channel dispersion. And lower beta values favor shorter, lower diversity paths, and while higher beta pushes for more diverse paths slightly long the routes. And then the two simultaneous flows under the flow load, the WCEDD continued to outperform ETX across all beta values. However, when the network is heavily loaded, a smaller beta delivered the best aggregate load throughput, since minimizing total airtime overtook the benefits of extra diversity. And the limitation is that the gains are most pronounced on short to medium paths, which is around less or equal to 4 hoops. And on longer routes, TCP sensitivity to RTD and loss diminishes WCEDD efficiencies. So we also found that including 802.11 backup in calculations yielded minimal remote benefits. And the group are here. The multi-channel MAC protocols required are variable changes, and then there is the traffic streaming starting at application transported in layers, and yeah, and these are the limited work. And the conclusion is that MRL2SR, also the source-rooted mesh protocol leveraging WCEDD metric to balance per link, airtime, and channel diversity. In a 23-node test bed with 2 heterogeneous 802.11 radios per node, WCEDD achieved up to 89 50% higher median throughput than EPX and over 250% higher than the shortest type protein. And then the tunable parameter beta. The tunable parameter beta lets the network operators navigate the trade-off between maximizing single flow performance and conserving spectrum. And then the future work is maybe the future work will scale to larger multi-floor deployments, investigate adaptive data selection based on real-time load and then more ideas per node, and the furthest performance and mobility. Okay, that's all. Thank you.
Maybe just 11 minutes.
12 minutes, right?
Neil. Oh, 12.
12.
Maybe just 10. That's okay, so any questions? If no, that's it and thank you.